Hi, everyone. Thank you for joining us for this session. My name is Anna. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional, and on topic. Keep an eye on the chat. We'll be dropping helpful links and checking for questions for our presenter to answer. The session is recorded. It's available to view on demand. I will now turn it over to our presenter, Simon. Simon, thank you so much for joining us.
Hello, all. Thank you very much, Anna, for handing it off. I am given the honor here to actually show you guys some cool things you can do with Azure Container Apps today. Today, we'll be building a music recommendation service similar to what you might be familiar with in the cases of Pandora or Spotify. So let's get started and dive in and let's take a look at the overview of this service and how it will be constructed. And then we're going to dive into actually building it using the Azure portal and the various tools we're going to be using throughout. All right, here we can see kind of the overall view of the service. There are on the right-hand side our inputs. In this case, surprise, surprise, this is a data set with about 11,000 songs that's available on Kaggle. And these songs are going to be processed, in this case, by a data scientist that will essentially use Jupyter. This is something that's very familiar with data scientists. We're going to be building fingerprints, or also called embeddings, for these songs throughout this process. And these will be stored in our vector database that is an ACA add-on, Azure Container Apps add-on. And then on the other side, this handoff will basically have a application developer build a backend that will connect to the vector database and retrieve the songs and the various embeddings, the recommendations, and then present this in the form of a front end that's, in this case, Java, to ultimately consume and take a look at. So let's go to the next slide. As I mentioned before, we kind of have two different types of engineers working together here. This is really a strength of Azure Container Apps, that it is very accessible on one end for data scientists that might be less infrastructure focused, have less experience interacting with infrastructure. They tend to be more data focused and experimental in the way they work, and they have very little or sometimes even no application developer experience. So that's on the one side. And here we're going to be developing these embeddings and playing with our data set. And then on the other side, we have the application engineers. These will essentially use the data that's being generated by the data scientists, consume it, and then they might be polyglot developers. In our case, we have a Python developer for the back end and a Java developer for the front end. And of course, they have more production application experience, so they're also more infrastructure focused. So really, I'm going to, as we go through this process, kind of call out which role I'm playing throughout, and let's get started. All right, so firstly, I'm going to be a data scientist and really play up kind of the strength that Container Apps has in this case. It's very much a self-service, even for the less infrastructure-focused developers. I blew this up a little bit, so forgive me if I have to scroll a bit throughout this process, but essentially I'm going to be picking my subscription. There's really nothing exotic about this. I already have a resource group, in this case, specified. I can just provide a simple name for my application. In this case, it's going to be a Jupyter application. Here I can go and specify the container. Again, as I specify, or as I mentioned before, the data science notebook is, in this case, the container that I want to run. This is very popular with data scientists. And then we can really kick this off. The data scientist, and for this process, it is beneficial to use GPU because creating the fingerprints for these services can be very time consuming, and we're going to see some of this as we get deeper into this presentation. But if you have GPU, if you have a GPU workload profile, in this case I don't, but you could basically select this here to speed up this process of generating these embeddings or fingerprints for these songs. We're just going to use the regular consumption profile for the sake of this exercise. And in a TV kitchen moment, I've already prepared this. So my application, in this case, it is called, or the notebook is called Music of Jupiter Full. I've connected this. Actually, I'm going to go back one more second here. As part of this process, I also need my need my vector database, and these are very easy to create here. So I can go and create my binding, which is essentially the connection to the vector database, and I can create or select. You can see either create. So if I wanted to create a brand new one, I could do that, which I won't. Or if there's already one in existence, I can select that and then basically connect it right through or right in my create mode. And yeah, and then I can go and create this process, kind of kick this off. But for the sake of speeding this demo up, I've already done so. As you can see here, we're connected to this vector database, in this case, Qdrant. And I also have a web interface that I can now bring up. And while this loads, I can connect here. And so now I am really doing the core work of a data scientist. In this case, and again, we'll be sharing a link for you to actually work through all of these details yourself and actually stand this service up from the ground up. But at a high level, this essentially is the creation of the service. And so we have some imports here. We're going to connect to the vector database, which in this case is very easy because we have this binding. We can simply pick up this environment variable and automatically we'll connect it to the right process or the right database. And you can see this already exists. I've done some, again, TV kitchen here to do the pre-calculations simply because it takes many, many hours. And then for the sake of this exercise, we also have an optional filter in this here as well. So if you wanted to only kind of create embeddings for a particular data set, you could do so very easily. In this case, we've disabled this filter. But if you wanted to enable this filter for just electronic data, music, you could do so. And then we can, let's see if we can actually, we can read some of this data in and actually then, all right, so we can see the data is massaged. We have it in the right format. We can listen to the song inside of this notebook, which is kind of the first process. And then now we can actually go to create our embeddings. Here, the code is prepared to either use CPU or GPU. And we're using a model called PANS embeddings. It is essentially something that initially was designed for the process of really identifying voice, but it actually works surprisingly well. And we're going to see this as part of using it for audio as well. And so we can actually run this right here. And this now downloads the model. This will take a little while. And we can scroll through, wait for this process. All right, great. So because we ran this the very first time, the model actually dynamically downloaded, and you can now see that we're generating these embeddings now. As you can see, we're using CPU in this case. If you follow the sample that will be made available as part of the URL, we will give you an option to actually use GPU as well. In this case, generating the embeddings for the 11,000 songs, as you can see, 11,294 songs on CPU takes roughly 35 hours plus take. And using GPU in this case actually speeds this up by 10x. So instead of the 35 hours, we're going to be using 6 hours plus minus. But we can just assume that this is now done. And as the last step, we're actually writing these away. I'm going to not execute this. Instead, we'll have another TV kitchen moment, and we'll just be consuming a ready, stored set of embeddings that we can now actually hand over to the application developer. And that's what we're going to do next. So here we have the rest of our application or the environment. You can see we just looked at our Jupyter notebook here, which is one application. And then we have the backend as well as the front end. And so on the back end, we're now going to go and visit the add-ons binding section for this application, because as you remember, we used the backend. We populated the vector database with these embeddings, and we're now going to go and connect our backend to this vector database. So I'm going to do a add-on binding. We're going to choose this Qdrant DB, and then we're going to go and say create. And once we do so, this binding will be established, and the backend will then basically serve these embeddings to the front end. So here's my front end application. Again, this is a Java application, and here's the URL. Are we ready to go? I'm going to click on this and see our songs. Again, I'm going to focus on electronic songs. That's just my personal preference. And you can see these are all the electronic songs. I'm going to pick let's see, Like a Virgin from Madonna. And we can see here's the song again. We can play this song. And maybe a little loud. Let's turn this down, and then we can get our recommendations. And again, these recommendations come through the backend and ultimately from the embeddings we generated earlier. And you can see we get recommendations. These are actually at the very bottom. We can see the scores. So these scores come from the vector database add-on, in this case Qdrant, and you can see a score of 1 is a perfect match. So Like a Virgin from Madonna would get 1 because it is the same song, and then anything in the 0.95 range is a very good match. And we can actually test this out now. So I don't know any of these songs, so let's see how good of a match they are. I'm going to turn down the volumes to begin with. Very much. This again, I would say there's a pretty good match. Very 80s, very pop. Let's try the second one. Also, if I like a Virgin, I would probably like Eurythmics by Thorn in My Side. Yeah, and that was kind of the overall recommendation service. Anna will make the link available as well for you to actually visit and deploy this yourself. I really enjoyed this because it really drove home the power of vector databases. It drove home the need for GPU for me for the very first time, really. And I enjoyed building and then also, of course, presenting this to you guys. Thank you.